Alright, welcome back everybody. My name is Dustin, and in the last video, we started working on the Tilemap Editor and the display for the tile set. There were a few changes made to our textures, the texture loader, and the asset manager. And we also created some nice template utility functions so we could easily get the keys from maps in the asset manager and use them in our IMGUI combo boxes. In this video, we're going to go over the challenge that was proposed in the end of the last video, where we want to create the new display, anew for the tile map, and we also want to create a grid system so we can have a grid that we're going to place our tiles on in that display. If you're able to get that done, awesome. Let me know in the comments below. Also, don't forget to like and subscribe if you haven't already. Okay, so let's get started. So the first thing we want to do is create the grid system, and we can just do that here. Let's close this and let's close this. And in our editor, we're going to want to create a new folder and call that systems. So here, add folder, and then we'll say systems. These are systems that will only be in the editor. So we have our new folder systems, and let's add a new file, and it's just going to be Gridsystem.h. Cool. Let that add. All right. Now we could probably do the whole grid with using just shaders. However, I'm just going to use the stuff that we already have with our batch rendering. We're just going to render rects at different sizes based on the canvas. Right now we don't have a canvas, but eventually we will. So right now we're just going to use a 16 by 16 tile to get the grid going. So if you have a solution on how to do that with shaders already, and you know how to make a grid with shaders, let me know in the comments below and I'll see if I can implement it myself. Okay, so for this we're going to want to do our pragma once. Then we're going to want to say we need memory for this, so include memory. Then we're going to say name space Scion Editor. And then we're going to have our class grid system. We're going to have our private, and we're going to have our public. Cool. So for our private variables, we're going to want to have the batch renderer or a batch renderer so we can do our recs. So which batch renderer are we going to need? Let's go into our includes rendering, and that would be core, and that would be the rect batch renderer. So let's do that now, and we can use either the glm vec4 or we can use the rect struct. So let's add that in. So rect batch render, let's copy this. And that's in Scion rendering. Let's go back to our grid system and let's just do a forward declare or forward declaration. So we'll say namespace Scion rendering class batch render, rect batch render. Cool. Now that we have that, we can create a unique pointer. So std unique pointer Scion rendering rect batch renderer mp, we'll just say batch renderer, batch renderer. Cool. That's all we're going to need there for now. We're going to probably add more things later on, but for right now that's pretty good for our variables, our member variables. So let's say grid system, do our constructor. The destructor can just be default. And we're going to have an update function. So we'll say void update. Okay, in order to update this, we're going to actually have to take in the camera. So we're going to want to do that as well. So let's go up here and forward declare the camera. So let's say class camera 2D. Come down here and we'll say Scion rendering camera 2D. And that's our camera. We're going to want to reference. And it's camera. Cool. So later on, we're going to have the scene object. So it would be something like this. Class scene object reference current scene. But we don't have that yet. Eventually, that's the goal, is to be able to send our scene in here. What scene we currently have loaded. That's the idea. We'll be doing this very shortly. Okay. So let's make these. So let's go to our systems. And you know what? We can just do it right here. Add gridsystems.cpp, new file, gridsystem.cpp. Yes. We're going to want to include gridsystem.h. We're going to want our namespace. That's Scion Editor. You could change it if you like. You can Scion Editor systems or whatever you like. And we're going to make these functions here. Cool. So in our constructor, all we're going to really have to do is initialize our batch renderer. So we're going to need to have a few includes here. So we'll say include core ECS main registry. We're going to include the rect. So rendering core rect batch renderer. Cool. Then include the camera rendering core camera 2D. And we're going to want to have our primitives and our vertex. So that's more rendering. These ones are in essentials. Essentials. And it's our primitives and our vertex. Cool. And we're going to need one more thing. We're going to need the asset manager. So include resources. That's under core. Resources, asset manager. We need the asset manager so we can grab our shader. Okay. Then here we can go mp rect or batch renderer. std make unique Scion rendering, and that's the rect batch renderer. Cool. And that's not taking anything in, but we have our camera here. Cool. All right. The first thing I'm going to want to do here is actually get the asset manager from the main registry, and we can just go auto reference asset manager is equal to main registry dot get asset manager. It doesn't like that. Probably because of how we define this. Yeah, so we have a semicolon there. What I can do is go here, remove that semicolon, and we should be happy. Here. Cool. You just got to remember everywhere that we use this macro, we have to put a semicolon. I've been doing that anyway, just out of habit, but make sure that you put it in if you haven't already. So now that we have the asset manager, the only thing we really need to grab from the camera right now is the camera matrix. Later on, we're going to want it to do some culling to cull out tiles or cull out some of the grid that's not in the actual view at the moment. But right now, I don't care about that. We'll end up doing that later. So we go auto cam mat, so camera matrix, so camera dot get camera matrix. Cool. And then now we have to get the shader, so auto p color shader. I believe that's what we called it. Let's say asset manager dot get shader, and I think it's just called the color shader. Cool. Let's actually just make sure that's what we called it. So if we go into our application.cpp, just look up color. Yeah, so we called it color shader, and it's color shader.vert, color shader.frag. Now let's see what uniforms that we have to make sure that we set, just to verify, because I don't remember totally. So not here, shaders, color shaders.vert. So we have, oh, that's the circle shader. Okay, so we have only projection. Okay, so that's all I really care about right now. We want to make sure that we set our projection. Okay, so let's go back to our grid system, and we'll say p color shader set uniform map 4, and that is projection. And let's just make sure it's just it's U projection. So make sure we copy that. Go back, U projection. And then we want to make sure that we send in the matrix. Cool. And right now we can do our batch renderer begin. So MP batch renderer, and we can just begin. If you remember with the begin done, it just clears everything out. Later on, we're going to have a canvas that goes in that'll tell us the tile width and also the width of the actual scene itself. And this is going to be something that we can change based on, so if you have a scene, there'll be a drop down. You'll be able to say you want to have 1920 by 1080 tiles and you want them to be 32 by 32 or whatever. We're going to be able to change that using the editor. But right now, we're just going to stick with the 16 by 16, 640 by 480 that we've been using recently. So int, and we'll just say tile width, and that's just going to be 16. and then tile height. Just ignore this right now because it automatically puts it down to the next line. This will all be in one line at the end. Tile height is also going to be 16. Then we're going to have, we'll say, canvas width. It's going to be 640 just so we keep the idea of the canvas. And then canvas height. Canvas height. That is going to be 480. Cool. All right. So now we need to know how many tiles are in the row and how many tiles are in the column. Okay. So for the width or the row, we go int col is equal to canvas width divided by tile width. And then we'll have the rows, int row is equal to canvas height divided by tile height. Cool. And we might as well make a color because I said before, if you remember in the challenge, I wanted it to be like a checkerboard. So we want to be able to change the color. Okay. So we can go Scion rendering color. This will just be the color. Just be default for now. So now we're going to want to loop through both the rows and the columns and set the tile color accordingly and also draw the rect or add the rect to the batch render. So we want to go for int I is equal to 0. I is less than row. Let's change this to rows and calls. I is less than row. And then I plus plus. Copy this line down. Change this to J. J calls and J plus plus. Cool. Now we want to create the checkerboard. So create the checkerboard colors. Okay. And an easy way to do that is to take the J or the row. We can actually, I like that better. Let's change this to row. Row. In row, row plus plus, call plus plus. There we go. That makes more sense. So for each row in rows and for each column in columns. Okay, cool. So what I want to be able to do now is to check to see if each row, so if I say row minus column modulo 2 is equal to 0 and column minus row modulus 2 is equal to 0, then I want to set it a specific color. If it's not that, I want to set it to a different color. So I want to say if col minus row modulo 2 is equal to 0 and row minus col modulus 2 is equal to 0. Then I want to set the color. Color is equal to 125, 125, 125, and 70. And then else, I also want to set the color, but to a different color. And this will just be 200. So we're looking for like a grayish colors. So both are like a gray color. One's darker than the other one. So this one's going to be, this is the darker color. This is going to be the lighter color. So let's say 200. You can make these whatever color you like. You can even make it variable if you like. Cool. All right, so now that we have our color, now I want to actually create a rect because our batch render, our rect batch render has a, let's go to this here. It has an add rect that takes in a rect. So we can send that rect in. And we don't have to send in the model because we're not changing any rotations or anything like that. So this should work fine. And the rect itself, I believe it does have color, so we don't have to send that in. Let's go check out the rect. Yeah, so it already has a color. So it has a position, width, and color. So we can just send that rect in. So let's go back into the grid system. And let's say Scion rendering rect. And we'll just say rect. Cool. And we'll say dot position is equal to glm vec2. And that's going to be static cast float, and it's going to be j times tile width, or not j, sorry, it's call times tile width. Cool. Copy this line down, and this one's going to be tile height, and that'll be the row. So the current row we're on, we can get rid of this. Cool. All right, so our position is the current column times the tile width. So if the column is 0, this is going to be 0. And if the column is 1, this is going to be 16, etc. Same with current row times the tile height. Cool. Now that we have that, we can go width, and that's equal to, and everything is floats, I believe, that we put in our rect. Yeah, so everything's a float. So we have to say static cast float tile width. And then height, change this to height. I know they're the same right now, so it doesn't matter if we use width or height, but they may not be the same later. You're going to be able to change it to whatever values, as long as it's not 0. So we'll have to put checks in for that, but that's later. And then our color is equal to the current color. Cool. Now that we have our rect, we can say, we can actually make this a little bit bigger. We can go m p batch renderer add rect, and that takes in our rect, and we don't have to send in the model, so we'll just leave it like that. Cool. And once we're done this, once we're done our loop, we can call the end and render for our batch render. So we want to say m p batch renderer end, and then we want to say render, and we can disable our color shader. Awesome, that's it. That's all we need for our grid system for now. Later on, we'll be sending in the current scene so we can get the canvas size and stuff like that, so we know how big to draw these tiles and everything, but this is good for now. All right, so now that that's done, we can go and create the Tilemap display. So let's go do that now. So let's go back to our displays here, and let's go add new file, and we'll say Tilemap display. .h. Yep, we want to add this in. We'll go back and clean those up later. Tile set display. Let's take a look at this real fast. Let's just go grab a few things from the .h file. Taking too long. So let's just grab everything here. Copy, Tilemap display, paste. Cool. We're not going to need all this. Let's change this to Tilemap display. Change this down here. So draw, set tile set. Nope, these can be removed. We don't need those. Cool. And this one we're going to actually need to override the update function as well. So update. And in here, we can get rid of this. If we open up our scene, like if you think about it, like if we run this right now, let's just run it real fast. It should build. Let's just give it a run. Okay, yeah. So you see we have our scene. Well, the scene has its own camera. And right now, this is at 4 scale. So we don't want to use the same camera. You want to actually be able to have them both on at the same time, because we can undock these, right? So you want to be able to, not sure why that didn't do as I expected, but anyway, we want to be able to dock these things, and we want to have our own camera for the Tilemap editor. So if I'm doing something in the scene, or if I'm doing something in the Tilemap editor, they're not affecting each other, okay? So the same, like when we hit play here, right now we're just taking in the registry of whatever tiles that are there, but in reality, what we're going to be doing eventually is you're going to be copying everything that's in your current scene that you have saved, and it's going to go into, we're going to copy those to the runtime registry, but we'll get into that later. So we're going to need to have a camera. So we're going to want to do our forward declaration. So let's say name space Scion render rendering class camera 2D. Cool. And we can add our camera here. So std unique pointer Scion rendering camera 2D mp tilemap cam. Now we could also add this into the main registry and basically have like another struct and call them editor cameras, which will have like a map of cameras, and we could access them that way, kind of similar to how we do the frame buffer. Speaking of which, we're gonna have to go make sure that we have the frame buffer added before we actually start running this, because we're gonna need it. Okay, so now that we have our cam, we're also gonna want to say private and have a function here, and this private function is going to be called void render tilemap. Cool. So let's go and create the Tilemap Display.cpp. Now I don't want to do it this way because sometimes now that I'm doing it with CMake, sometimes Visual Studio will just crash. So I no longer want to do it that way. I'll just make it this way and then copy the stuff over. So here, display, new, add Tilemap Display.cpp. Cool. Yep, I want to add it in. And I want to include Tilemap Display. I want to say namespace Scion Editor. Cool. Now that we have that, I can come back here and let's make all these functions. It should make them faster. Cool. Made them. Everything's good. Except we don't want this to be default anymore. I actually want to create this. I want to be able to initialize my camera, and we'll do that here. Cool. So let's add a couple includes that we're going to need. We're going to need our main registry. So core, ECS, main registry, include core, resources, asset manager, include rendering, core, camera. That's another thing. So since we're going to need our own camera here, we're going to want to, so right now let's go take a look at the render system and all of the rendering systems, right? So render system.cpp. So the thing is, it's grabbing the camera from the registry, right? But we don't need to create a new render system for each thing. We can just reuse the render system. So we'll just hold on to the render system in one of the registries, probably the main registry, add it there. And then when we need to use it, we'll just grab it. So right here, we can just add in what registry we want to do the update for and what camera we're going to use. We can put that into our update function as arguments. But we'll leave this for now. And we'll get done the Tilemap display. What we have done, just all I want to do is display the grid today. But next time, and maybe even a challenge for you, the challenge could be remove the dependency here on the registry and add that in here to the update function as something that we take in. That we take in a registry and we take in the camera and we do everything from there, because it could be a different render system, because you're going to have a render system we're going to be rendering in multiple places. Why make multiple render systems? We could just use the same one because they're rendering at the same time, but it's also, we're not multi-threaded. If we can just use the same one, because it'll technically be only running, it'll look like it's the same time, but they'll never actually be at the same time. Okay, so let's go back into this. So just like before, all of our rendering is going to be happening inside of here, and it's going to happen in our draw function. It's going to do all that stuff. So we need to bind our frame buffer and everything inside of here, okay? So let's go back into application.cpp and make sure that we're adding in the frame buffer for the Tilemap editor. Yeah, so see, we're still doing this here. All this is going to have to be moved eventually. Actually, let's take a look at our scene.cpp, scene display. I could have swore we were already doing that in the scene itself and removing everything. So we're going to have to do that as well. So let's go back into application.cpp. All right, so I thought I already added in some multiple frame buffers, and looks like we haven't done that yet. I totally thought I did that, so we're gonna have to we have an issue right now. We're gonna have to, right now we only have the one frame buffer, and I'm gonna need different frame buffers for different things. So right now, this one will be like our scene frame buffer, and we're also gonna have to have the tilemap frame buffer, or maybe like a UI display. So there's gonna be different frame buffers doing different things. So we can't do it this way. Well, we probably can, but we don't want to do it this way. So we're gonna have to create something else. So this is actually gonna change the video a little bit because I totally thought I did this already, but that's fine. So let's add this in. And so what we'll do here now is go into our utilities and go here, go new file. And we'll call this editor frame buffers .h. Cool. Yep, we want to add this in. And this is going to have the frame buffer. So we can say pragma once. And we can include our rendering. I want to include our frame buffer here, non-essentials, say buffers, frame buffer, instead of forward declaring it, because I want it to automatically be there when we include this. You're probably only going to include this in your .cpp files anyway. Then say namespace, Scion Editor, and I want to have a enum class for the frame buffer type. So we say enum class frame buffer type, and that's going to be tilemap. Then we're going to have scene, and that's good for now, and then we'll just say no type. Cool. And all of this is going to be a simple struct, and it's going to have the editor frame buffers. And it's just going to be an std map, not make, map of frame buffer type, and std shared pointer to a Scion rendering frame buffer. Cool, and I'll call this map frame buffers. Cool. The reason why I'm putting this into a struct is so I can easily just add it to my editor context, or my registry context, sorry, and then just grab it when I need it. So this will go to the main registry context. Cool. So now that we have that, let's go back to the application.cpp, go up to the top. We're probably going to have to remove some of this stuff because it's not needed in here anymore. I'll start doing that later though. So let's go right here. So we have our utilities, editor textures. Let's change this to be the editor frame buffers. Cool. And then down here, right where we're adding in our frame buffer, we do it somewhere. Right here. So we create our temporary frame buffer. You know what? And while we're here, we might as well add in the grid system. So we'll add that in as well. So we can go here and go include editor systems grid system. We're going to also add this into the main registry because we're only ever going to need to use it in the Tilemap editor, I believe. So that's where I'll just grab it from the main registry. Cool. And let's go down here to our frame buffer. So instead of adding it to this registry, eventually we can remove this registry because each scene will have its own registry. This was just temp stuff that we were adding in. And so here, let's just get rid of this totally actually. Auto P editor frame buffers. do std make shared editor frame buffers. Cool. Then we can add this to our context. First, let's just see if it's not there. Fail to add editor frame buffers to context. Cool. Oh no. Fail to create editor frame buffer. Cool. And then adding to the context, we want to remove this editor frame buffers, and this is the editor frame buffers. Fail to add the editor frame buffers to registry context, but we want to add it to the main registry context. Cool. So we can get rid of this because these aren't going to be temporary anymore. Eventually we're going to be able to change the actual size of these frame buffers. Again, right now they're still going to be default 640, 480, but that's fine. So we can say p editor frame buffers map frame buffers dot in place, and we're going to say frame buffer type, and the type is going to be the scene. And then we're going to say std make shared Scion rendering frame buffer 640, 480, and use RBO. We'll just say false for now. Cool. And we can just copy this, not this, copy all of this, and do another one for the tilemap. Cool. So now we have two frame buffers, one for the scene and one for the tilemap. Awesome. So if we go down, eventually we're going to want to remove this stuff in our rendering function. Where is that? Here. All of this, like all of this is going to be removed from here. Let's see what we can remove right now. So we have this, all of this here, we're getting our frame buffer. We're not going to want to do that. We could probably, yeah, we're not going to want to do that. So let's just actually go to our scene. And so just like our tilemap display here, where we have a render tilemap, we actually want to go into our scene and add one of those in for render scene. So let's go to that now. So displays, scene display here, load scene, unload scene, and then void render scene. Cool. Let's go into our, let's actually make this. And we're going to want to do this right before our image button. So let's do that right here. So we're rendering the scene here. And what can we render? So let's go to our render scene. So eventually we're going to be getting the current scene, and we're going to have a scene manager, but we're not doing that just yet. So we're going to want to get the main registry. So grab this, go main registry, and let's get the frame buffers. So we go auto reference editor frame buffers, editor frame buffers. That's going to be equal to main registry dot get context, and that's the std shared pointer of editor frame buffers. So it doesn't know what that is, so we need to add in the include up here. Include editor utilities editor frame buffers. Cool. Go back down. And we're also going to want to get the renderer and do all that stuff as well. So let's go up here and make sure that we're getting in the renderer. Where's rendering? Right here. So let's grab the renderer. Renderer. Cool. Let's go to our application. I'm not sure where we put the renderer. And all we did, we put it in the regular registry. Okay, so we're not going to want to do that. Let's go up into our main registry. Let's just copy this. Go up here. Where are we adding our renderer? Renderer. Let's get context. F3, F3. So right here, we're adding the renderer to the context. I want to change this here to main registry. Move this down here. Cool. And let's go down renderer. Not there. Here. And we can basically grab all this stuff here. Okay, let's actually grab everything. Yeah, so let's grab all of that. Go back into our scene display. Go back into our render scene. Cool. And I don't want to be doing this. We're already getting our editor frame buffers here. So now I need to get the specific frame buffer. Sconce auto, and we'll call it, yeah, we'll just leave it frame buffer. It's equal to editor frame buffers. Map frame buffers at scene frame buffer type. Cool. Right here. That should work for us. And now we also want to get the renderer. So let's get that up here. So let's go auto reference renderer is equal to main registry get context std shared pointer Scion rendering renderer. Cool. Now we have our renderer. We're also going to want to check resize down here as well, because all that's going to be moved. So the only problem we have now is let's get rid of that. We need the render system and the shape system and all of this stuff. And this one takes in the registry for the UI system, which is something that we want to do for all systems eventually. So right now, do I even have the registry? Yeah. So we're sending this registry in, which is great. So I automatically already have it. So we can get the render system from this registry because that's where we're already putting it. But I'm not going to want to actually get it in this registry anymore. So let's go back to application. And where are we getting that? Yeah. So let's remove all these from the main registry. So this is not there anymore. Get rid of that. Cool. And we already moved all this over. We can get rid of these. We can get rid of this. Get rid of this. Cool. Get rid of this. Did I do this already? We'll just get rid of this for now. So now I have to do something about these render systems. So let's go up to where we're doing these. Get rid of this. And let's add these into our main registry instead. So right here, change this to our main registry. Change this one to the main registry. Awesome. And we might as well put this one in the main registry as well. Cool. Those are all in the main registry now. And we'll leave the animation system for now in this registry. But eventually we're going to want to move all this stuff. Like where are we doing our update for our animation system? So the update is already being done in the scene. I don't know if we're actually, I have to look at it. I totally thought we were further ahead. Okay, so the check resize is not needed here anymore because we'll already be doing that. So now that we have these systems, all we have to do is go and get them. So let's Copy this. Go into our scene display. And we're going to have to get these systems. So we'll put this right here. And we'll leave this as M registry. For now, all this is going to have to change. Wait, these are coming from the main registry. So let's actually take this. I want to copy this. Go up. Oh, it's already using systems. So now we already have our animation system, render system, render UI system, and render shape system. Cool. I should clean this all up. And get rid of these. We still want this registry for now because we don't have the scene idea, the idea of a scene yet. So we're still going to want to use this registry for now. But eventually we're going to have to send these all in. Okay. So bind, unbind, color, set the viewport, clear buffers, and update. Yep, that's good for now, I think. All right, so let's go back into our application.cpp and we can actually remove everything here, I believe. Yep, we can just remove everything from here. And now when we go here, this should actually draw all of our stuff here in our displays. Cool. Oh yeah, here's another thing. When you're adding in, if you want them to tab on each other, you just add them to the same node, and then it'll just be a tab. So let's run it and hope that works. There was a lot of weird changes I made there. I totally thought I did already. So let's run it and see if it works. A little side from doing the Tilemap display, but this is going to be needed in order for us to do the Tilemap display as well. Okay, so we broke some stuff, and that's fine. We want to see what we broke. So here, we're trying to get a frame buffer, scene display, this here. So we're trying to get this frame buffer. We need to change this now. Are we calling the main registry here? Yes, we are. So in the main registry, we just need to get our editor frame buffers. Just like up here. So editor frame buffers, we can just copy this. And we can just put this here. And this is equal to editor frame buffer dot map frame buffers. Sorry. At the frame buffer type scene. Now we could put a check-in for this, but we know it's there, like it's created already. You could put a check in to see if it actually exists, but we're gonna leave it as is. And let's stop this and try to run it again. That should be everything. Yep. Now we just gotta make sure that everything still works. Okay, and let's run the scene. And we got a crash. And that's fine. That's the whole purpose of this. We got to fix all the bugs that I just created. And we'll see what it is. Register Lua bindings here. So create user data. So yeah, I'm trying to do it with this registry here. So I'm sending in the registry. I'm already getting the main registry here. We're sending in this registry. I can just change that to that. Any other ones that I may have to change? Where's the camera coming from? The camera is still coming from this registry, and that's fine. We'll leave it there for now, and we'll come back and fix this later, same way. So we'll stop this and run it again. Yeah, refactoring, you have to go through these panes. And that's fine. And hit play again. And it's working! Awesome! Oh yeah, so I turned that off to see how... I was doing a little test to see how many entities I can have in the scene before it slowed down dramatically. And I got bored at over 3,000, and it just kept running normally. So right now these aren't dying. We're not updating them. They're just falling forever. And we can just keep adding them, keep adding them. It doesn't matter. So all I did was comment that out in the Lewis script, and we can just keep adding them forever. So those are just falling and falling, and yeah. So anyway, so cool. Our scene is completely rendering. We completely changed that. So if we come back to our application.cpp, let's take a look at our render function now. All that stuff that was in the render function is now gone. We only have this here. So basically it's just IamGUI calls, and everything is being done in its respective display. The render function itself is calling each display, and each display is doing its own thing. And that's what we eventually wanted to do as well. Oh, we have this here. What did I miss? This should be a break as well, I believe. Cool. And now that we have that concept, we can take that everything that we just did in the scene display here and move into our render scene. We kind of want to do the same thing now with the grid system, and we want to do the binding and all of this inside of our render tile map. So let's go to our tilemap display, and let's fill this all out in our render tilemap function. So we're going to need to get the grid system, so include editor, systems, oops, that's utilities, systems, grid system. What else we're going to need? We're going to need our editor frame buffers, so include editor utilities, editor frame buffer. We need the renderer, so include, we can do that up here. Bring this down. Renderer. Cool. And we might as well add our logger in. Don't know if we need it, but we'll add it in anyway. So let's say logger, and we're going to need IamGUI. H. Awesome. So the first thing we want to do is our render tile map. We can actually, you know what? Let's just go to our render scene in scene display and grab everything here, because it might be, we might be able to reuse it. And we'll bring this to the Tilemap display, paste that in. And right now we're not doing any systems, so we'll just comment this out. Comment this out, because we're probably going to reuse this later. Cool. And we have the renderer. This one is going to be the Tilemap. Right here, we're going to want to get the grid system. So we can go auto reference grid system is equal to main registry dot get context std shared pointer of the grid system. Cool. And all we need to do right now is, since we're already in our binding, we can just go grid system update, and we have to send in the camera, and that's just our mp tilemap cam. That's a reference. Cool. Unbind. Cool. I think that's all we need to do there. I'm not sure if we have to clear our buffers after everything. We will, just in case. I don't think we do. If anything, we'll come and take that out. All right, so I think that's good enough for our render tile map. So what we're doing is we're grabbing the main registry, getting the editor buffers, getting our renderer so we can do our viewport stuff, getting the tile map frame buffer, binding our frame buffer, drawing our grid, and then unbinding and checking the resize just in case we are resizing the frame buffer. Then we're doing some clearing here. Cool. And here we need to actually make our camera, so I forgot to do that. mp tilemap cam std make unique Scion rendering rendering camera 2D. So right now we're just sending in the default for the camera, and the default I believe is 640/480. If we come here, check this out. Yeah, 640/480 is the default for our camera, which is great for now. Eventually we're going to have to set this based, and we're going to have to be able to change it based on if our canvas and all these things change for us. Cool. All right, and the draw function for this one, we want to go if not I am GUI begin Tilemap Editor I am GUI end and return. Let's copy this, go down here. Cool. And right now let's just go render tilemap. So we're rendering the tilemap. Let's get our main registry. So auto reference main registry is equal to main registry. And now I want to create a child for our window. So a child window. So go if I am GUI begin child, and we'll just say tilemap I am vec2 0 0 false. And eventually we're going to be wanting to zoom in with our camera using the mouse wheel. So we don't want to be able to scroll with the mouse for the tile map. Okay, so I want to say I am GUI window flags no scroll with mouse. Cool. Then we say I am GUI and child. Cool. So we're basically want to do the same thing. So we rendered everything to our frame buffer here. So I need to grab the frame buffer texture now, and I want to render that to the I am GUI image. Okay. I'm also going to want to center our grid to the center of the window. Okay. So let's get our frame buffers. We can just copy this here and go down here, paste. Oh, we need to get it from the main registry first. And we did that up here already. So we have a frame buffer, and I want to get an image size from the tilemap frame buffer width and frame buffer height. So I want to go I am vec2 image size, and that is static cast float tilemap FB, and that's just the width. Copy that down, change this to height, get rid of this. Awesome. And let's get the window size. I am vec2 window size, and that's just I am GUI get window size, get window size. Oh, get rid of that there. So now I want to set the current XY position, and we're going to do that by going float x is equal to window size dot x minus image size dot x, and multiply this by 0.5f. Copy this down, change this to Y, change this to Y, change this to Y. Awesome. And once you actually have the position, the center position, you're going to want to set the cursor position. So you want to go I am GUI, set cursor position, and just send in X, or sorry, I am vec2 X, Y. Cool. Now that we got here, we can actually create our image. So I want to go I am GUI image, and this image is going to be based on our frame buffer. So we can just cast the I am texture ID for the tilemap, or the FB get texture ID. And then I'm going to want to send in the image size. And then I'm going to say I am vec2 0 1 0.f 1.f I am vec2 1.f 0.f. Cool. And I believe that's it. I believe that's all I need. We also need to do the, oh, that's hilarious. Hopefully you guys saw that. I was doing that all in the update function. Let's get rid of all of this. Not get rid of, but move it all into the draw function. That's where I want to put it. Sorry about that, guys. I kind of got sidetracked earlier with the scene display stuff and the frame buffer stuff that I thought I did previous. So now in our update function, I just want to update the camera. So mp tilemap cam update. Cool. And that's our tilemap display. So all we're doing now is rendering our grid system to a frame buffer inside of our tilemap display. Okay. Eventually we're going to have different tools that allow us to place tiles, and we're going to slowly start working on this. It's going to take some time, but we're going to get it. We're going to get into it. Okay. So now that we have our display, we want to go and add our display into our display holder. So let's go back to the application.cpp. Let's go to displays, create displays. So we have our display holder here. Oh, before we get to this, I need to go back up to the top. Where are we doing our displays? Tile set display, tile map display, tile map display. Cool. And let's go to where we're creating our displays. Or actually, let's go to render I am GUI first. And let's make sure that we're docking our tile map. I think it's editor. I think that's what we wrote. Editor. Let's just go verify. I want to dock it with, or tab it with, the scene node or the center node. Let's go back into our tilemap display, and we called it Tilemap Editor. And you know what? I'll just copy this to make sure. I'll just place this in here. Cool. And we can go to our create displays here, and we can add another display. So just copy the tile set display, paste, back it up, change it to tile map display. Failed to create the tile map display, and we just want to add it in right here, tile map display. All right, now this should work. It should do all the rendering for us, but we'll see if there's any. We'll run it and see if there's any bugs, and let's go. And we have an error here. Exception thrown. Grid system was null pointer. I swore that's because we must have never added the grid system. So let's go to application.cpp. I swore we added the grid system. Grid system. No, we did not. All we did was include it here. So we need to actually add that into our main registry. We can just do it. It doesn't really matter where we do it. We'll just do it down here, right after this frame buffer stuff. So let's go. Let's copy this. We'll just do it all in one liner. std make shared. Don't know why it keeps picking shared for overwrite right away. And I want to say grid system. No, doesn't like that. Oh yeah, the grid system. Cool. So we're just automatically adding it in, and not really caring if it fails to make. That's fine. So fail to add the grid system. Cool. Let's just run it. And there's our Tilemap Editor moment of glory. Oh, it's all black. Okay. So does this work? So this still works. And this is all black. So I need to figure out why. Cool. Oh man, you guys probably saw this already. So we're getting the shader and we're doing some setting stuff, but we never actually enabled the shader. So p color shader enable. All right, let's try again. We should also check to see if the shader is valid, but bam, and there's our grid. Awesome. So right now it's 16 by 16 tiles. Eventually we're going to want to be able to change the size of these, and we can go back into here and let's just change our size to 32s. 32 by 32 and go in. Awesome. So yeah, that's exactly what I wanted to do. So we actually did a lot in this one. In this one, we created the Tilemap. We started the Tilemap Editor display. We created the grid system to draw the grid for us. And we also changed how we are updating the scene. So now we actually have both of these are rendering at the same time, and they have different cameras and they're doing different things, which is great. And in the next video, we're actually going to start getting into creating the scenes themselves. I was thinking to either do the scenes in the next video or start the asset display. So we'll have another display down here, which when we will show all the assets that are in our asset manager. We could do that one next, or we can start getting into the actual scenes and scene management next. The asset manager or the asset display is different than the content display. Content are the files that you have in your content folder that you'll look up for the project directory. But the asset display is the stuff that is converted into textures and stuff for us to use. Because you can have your content, but any textures or assets still need to be converted into proper assets for the game. Let me know in the comments below which one you want to do. If you want to do start getting into scenes and scene management, or you want to do the asset display. Let me know below and I will make the video based on that. All right, so that's it for this episode. There actually is a little challenge if you want, and that's to go through all of our systems and remove the render or the registry dependency that we have here, and just send in the registry for the update functions. Okay. All right, so that's it. Take it easy.